In this lesson, we're going to take a look at some integrating with trigonometry. So we're going to start by looking at a couple situations that have integrals of trig functions and see how we can creatively work with that. And then we're going to look at some integrals where we don't have trig, but we can use trig to help us out. All right, so first we're looking at what happens when we have an integral that is a product of sine and cosine. We'll find some strategies for that, or an integral that we have a product of secant and tangent. Okay, and the key here is that we know that sine and cosine are derivatives of each other, and secant and tangents are derivatives of each other in a way. All right, okay, they're related. So a couple of useful tools that we'll use. We've got the good old Pythagorean identity, 1 equals cosine squared plus sine squared. And there's different versions of that, but they all come from this. We can solve this. We can divide by cosine, and we get a one involving tangents. We could divide by sine, and we got identity involving cotangent. So anyways, also, we have our power reduction formulas. So we have this formula that says sine squared is 1 minus cosine 2x over 2. And we have the cosine squared version of that, which is 1 plus. They look a lot alike, but cosine is plus and sine is subtract. All right? Okay, we're all set. Let's get into it. So some strategies here, right? Here we have a product of sine cubed and cosine to the fourth. Since the sine power is odd, then we want to save one of the sine x's for du. Okay, and we'll change all the rest to cosine. Okay, and the idea is our goal is we want to use u substitution. So we'll rewrite this as cosine to the fourth x times sine squared x times sine. You probably don't have to write this step out, but I'm going to write it so we see it, sis, here. Okay, and well, what is sine squared there? Sine squared is 1 minus cosine squared, right? So we can solve for sine squared in the Pythagorean identity, and we get 1 minus cosine. So we have cosine to the fourth of x times 1 minus sine squared x. 1 minus cosine times sine x dx. So we can say, let's let u be cosine of x, and that means du is negative sine x dx. Derivative of cosine is negative sine. All right, well, that brings us up to here, so this is equal to the integral of, we have u to the fourth, and we've got minus 1 minus u squared. And, we got to wait just a moment. We got sine. We don't have negative sine, so I wish this was negative. I wish we had a negative in here, so we can do that. If I put a negative in here, I need to put a negative or negative 1 out here. All right, so negative 1 times negative 1 is positive 1, so I haven't changed anything. But now inside here I have negative 1 sine x dx, and that is du. So I'm going to replace this negative 1 sine x dx with du. Okay, so we've got to make sure we have the exact replacement there, including the constant. So, all right, well, there you have it. We should be able to do this pretty easily. Distribute that u to the fourth minus u to the sixth du. And now we can use our power rule. And so this is equal to the integral. Let's go and take the integral. Okay, so this is equal to u to the fifth over 5 minus u to the seventh over 7 plus c, which u we said was cosine x. So let's rewrite it, and we're done. Cosine x to the fifth minus cosine 7 to the seventh plus c. Okay, there you have it. All right. Well, what if we have something like cosine to the fourth here? So we don't have any signs here, so we can use power reduction here, all right, to drop this down, all right. We know the integral of cosine, but we don't know the integral of cosine to the fourth. All right, so let's dive into this here. So we have our power reduction. Now notice this is cosine squared, so we're going to have to do a little extra work with the fourth here. This is cosine squared of x squared, if you'd like. Okay, so that equals, let's start using our power reduction, 1 plus cosine 2x over 2 squared. Okay, now if we square that function there, we end up with, the bottom squared is 1/4. I'm just going to pull that over here. Okay, and we get we're going to square the binomial. So we square the first, square the second, multiply and double. So this is like a plus b squared. Square the first, 1. Square the last, cosine of 2x squared. And then we multiply and doubled, so 2 cosine 2x in the middle. All right, that 1/4 can get pulled out. And we're going to need to rewrite this cosine 2x one more time. All right, cosine squared that is. So let's do that. So we have the 1/4 integral of 1 plus 2 cosine 2x. And this is going to be plus 1 plus cosine. Now cosine of 2 times this angle, it already is 2x. So we need to double that, 4x all over 2. Okay. And now we have no powers. That's kind of good. And we've got these 3 different parts. So let's kind of rewrite this one more time. Let's bring it over here. So we have 1/4 outside. We've got 1 plus 2 cosine 2x. And let's divide both of these by 1/2, or by 2, I should say. 1/2, and then plus 1/2 of cosine 4x. All right, and we're about ready to go there. Maybe let's go ahead and put these together, the 1 and the 1/2, and then I think we're ready to take our integral. So 1 plus 1/2, 3/2. Can't just pull that out, by the way, because it's a plus. I'm going to have to deal with each of these separately. 1/2 cosine 4x. Okay? All right. Here we go. So we have 1/4. I think we can take our integral here. Okay. So when we integrate 3/2, well, that becomes 3/2 times x. Okay. Now we need to integrate this part. So we're going to need to use a little u substitution here. And we say u is 2x, so du is 2 dx. And look, we have the 2 out there. So this is all good, all right? So this is sine of 2x. And you can double check. If you take the derivative of sine of 2x, you get this, right? Because you need to use a chain rule to take the derivative of that to get that, okay? Excellent. And now we have the derivative of 1/2 cosine 4x. Well, okay, we're going to need to use a little u substitution here, okay? And we'd want u to be 4x. That means du is 4 dx. We don't have a 4 out here, okay? We would like this to be a 4. You can think of this a couple ways. So We would like this to be a 4, so we could put a 4 here. There it is. And we could multiply by 1/4. I didn't really change it there. 1/4 times 4 is just 1. Okay. And so now I got this 1/8 there that is going to kind of hang out there. And now the integral of 4 cosine 4x is sine of 4x. And there you have it, plus c. All right, and we could distribute that 1/4 and be all cleaned up, I guess, there. Plus 1/4 sine 2x plus 1/32 sine 4x plus c. All right, a lot going on. It's a challenging one there, so we'll leave it at that. All right. Another good strategy here, we can change things to sines and cosines. Let's try that here. We got the integral of secant over tangent squared. So secant is 1 over cosine of x. Tangent is sine over cosine, so sine squared over cosine squared of x. Okay. Then we can, that's dx. Okay. We can simplify this in a couple ways. We can multiply by the greatest denominator here, the common denominator, you might say. So this is, if we multiply by cosine squared, we get cosine on the top because one of these cancels with one of those, and sine squared on the bottom. Oops. Okay. All right, now we got down to our sines and cosines, and let's see what we can do with that. A little u substitution. If we say u is sine x, then du is cosine x dx. Derivative of sine is cosine. And that leaves us with the integral of du over u squared. Okay, and so this is just integral of u to the negative 2 du. And let's add 1 and divide. So this is negative 1/2 u to the negative 1st. Last but not least, that gives us with negative 1 over 2 sine x plus c. All right. So there's another strategy. Going to sines and cosines can help because we have that u substitution. Derivative of sine is cosine, and derivative of cosine is sine, negative. All right, so there's some strategies when we have trig in the problem.